NASA issued an urgent warning. Pluto is not what you think. What is NASA alluding to here? Are they referring to the latest findings from the New Horizons space probe, which show that strange things are happening on Pluto's surface? One of the explosive images actually shows an object that appears to be gliding across the surface of Pluto. This raises disturbing questions as to whether some kind of previously unknown life exists on this distant world, or if we are dealing with a strange geological phenomenon. Pluto may be small, but the stories it has to tell are big and full of surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the data from the New Horizons probe, which only reached Pluto 9 years later. Since then, we have known that there is far more to this little guy than was assumed. How did astronomers come to deny this planet, which we have all somehow grown up with, the status of a real planet? The issue arose after the discovery of numerous other tiny planets in the Kuiper belt. This led to the need for a boundary between what constitutes a planet and what is a dwarf planet or trans-Neptunian object. Pluto scores points for its size and round shape, but it shares its orbit with several other objects. The orbit is therefore not considered to be cleared, and this was precisely the reason why Pluto was no longer included in the list of large planets in the solar system. Many people on Earth think this is a shame, and this decision by astronomers caused consternation among the population worldwide. Pluto was no longer a planet, and many simply couldn't imagine it. It's crazy that this small planet has so many fans on Earth. There were letters of protest to NASA, famous scientists who spoke out in favor of the demotion, and even governments received letters from angry citizens demanding that Pluto be a planet again. This planet has been with us since the 1930s and has since been part of a series of 9 planets. As if to advert to this, in 2015, when New Horizons sent us the first real image, the previously excluded minor planet showed us its cute face. Imagine it was the first real image of Pluto. If you've seen the planet on blackboards or in school textbooks before, they were purely artistic representations and not real images. Pluto had denied even the Hubble telescope a clear view of its face. Only New Horizons was allowed to photograph the little one as it really is: colorful, friendly, amazingly lively, and with a heart. Since then, the planet on the outer edge of the solar system has won over even more friends, and perhaps astronomers will change their minds one day and we will get Pluto back. The first real images of Pluto took everyone's breath away. It was a magical moment when the first data from the New Horizons probe arrived at mission headquarters in 2015. Everyone present knew that they were about to see a planet for the first time that everyone was somehow familiar with but had never seen up close. The computers on Earth assembled this fascinating image from thousands of individual bits and pixels. What the probe revealed about Pluto was a revelation that completely turned our understanding of this distant planet on its head. Pluto is much more varied, much more structured, and much more alive than planetary researchers had previously assumed. In addition, the small planet appeared to be covered in landscape forms and possibly even weather phenomena. Nobody had expected that either. With every new bit that New Horizons transmitted, the blurry, mysterious world in the darkness of the Kuiper belt became a tangible object that showed so much life it took scientists' breath away. More and more surprising geological wonders opened up before the researchers' eyes. Instead of the expected icy and cratered wasteland, Pluto turned out to be a dynamic place with majestic icebergs, deep canyons, and smooth glacial surfaces. It took years for the countless measurement data, photos, and findings to make the long journey from Pluto to Earth. Since 2015, we have been surprised again and again with new fascinating aspects about Pluto. Who is that walking on Pluto's surface? It's shocking. This moving image circulated in the media in 2016. But what can you see here? It looks as if a person is walking across a strange honeycomb-shaped snow drift. You can actually see ice landscapes here, but unlike on Earth, these frozen surfaces are not made of water but of nitrogen and methane. Researchers identified the strange object as a dirty iceberg, which appears to be gliding over the surface of the ice-covered plain. The massive block of ice is most likely also made of extremely solid nitrogen. These bizarre-looking landforms revealed something very special to researchers. They now believe that there is a nitrogen reservoir several kilometers below Pluto's surface in which the solid blocks form. Geological activity in the interior of the planet pushes these blocks upwards, creating the honeycombs and structures such as the apparently wandering mountain. This points to a warm core of the planet, and this finding alone is a sensation that could have far-reaching consequences for our understanding of Pluto. Pluto is far more active than assumed. Geological activity from heat and shifts in surface structures indicate a kind of aliveness that shows we have underestimated Pluto. This little guy not only has a heart but fire in it, and that could even mean that there are pockets of liquid inside Pluto that resemble oceans or magma chambers of ice. The head of the geology team of the New Horizons mission, William McKinnon, even compared the inner life of the dwarf planet to a lava lamp the size of Hudson Bay in Canada. Computer simulations showed that this impressive landscape developed over millions of years and is still extremely active today. Can you see the distinctive X on the right below the iceberg? This formation was probably created by sublimation. A substance changes directly from a solid to a gaseous state and the liquid phase disappears. These processes occur due to the extreme temperatures on Pluto. Mysterious geological processes and weather phenomena in a dead world. Christmas in the snow on Pluto. Does that sound crazy to you? Well, it's a fact. Pluto really is a surprise. The New Horizons mission revealed fascinating aspects of the climate and seasonal changes on this planet. Pluto, which orbits in the cold, distant regions of the Kuiper Belt, experiences significant seasonal variations due to its eccentric orbit and tilt. The New Horizons space probe discovered that Pluto's atmosphere, a thin layer of nitrogen, methane, and carbon monoxide, changes dramatically depending on how close or far Pluto is from the Sun. The changes affect not only the atmosphere but also the surface conditions of the dwarf planet. One particularly remarkable aspect of the climatic dynamics is snow on Pluto. This consists mainly of frozen nitrogen and methane. Unlike on Earth, where snow only forms from water, the extremely low temperatures on Pluto cause the far more volatile gases, nitrogen and methane, to condense and fall as exotic snow. All these processes shape and renew Pluto's surface by covering the landscape with fresh deposits. The upheavals in turn drive other geological activity in the form of glacial movement and possibly even cryovolcanic processes.
The New Horizons research also showed that these seasonal cycles are closely linked to atmospheric density. When Pluto is closest to the Sun, the sparse light is enough to slightly warm up the dwarf planet's atmosphere, causing it to expand slightly and rise. When Pluto moves away from the Sun again, the atmosphere freezes and sinks back to the surface. This dynamic leads to a remarkable phenomenon. When Pluto's atmosphere condenses, it could literally snow, with snow consisting of nitrogen and methane. The variations in surface brightness and the distribution of icy deposits further suggest that almost all surface features and landscapes on Pluto are associated with these atmospheric cycles. Since Pluto's mountains are not made of rock but of ice, which is very dynamic in this world, the entire surface moves far more than that of our Earth. For example, what is Pluto's heart made of? Who would have thought that Pluto's heart is not just a pretty spot? In addition to its prestigious appearance, this region is also one of the most exciting regions on the planet, officially called Sputnik Planum. The region is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This large heart-shaped ice surface extends over an area of around 1,000 kilometers and consists mainly of nitrogen ice with inclusions of frozen methane and carbon monoxide. The bright, almost flawless surface of Sputnik Planum forms a stark contrast to the darker, more complex regions around it. Geologically, Sputnik Planum is a gigantic impact structure that was probably later altered by volcanic processes. Unlike typical volcanic activity on Earth, where lava emerges from the Earth's interior, cryovolcanism on Pluto involves icy materials emerging from the dwarf planet's interior to the surface. The heat sources in the depths of Pluto cause nitrogen and other volatile substances to heat up and push upwards, where they freeze and form unique formations like Sputnik Planum. Sputnik Planum is remarkably flat, which leads researchers to conclude that the icy surface is regularly renewed by internal processes. It's probably convection processes within the ice sheet that shape these landscapes. Researchers suspect that there may be an ocean of liquid water beneath the smooth ice sheet of Sputnik Planum, which is kept liquid by the heat inside Pluto. Researchers doubt whether forms of life can exist in the subglacial ocean, but it's not completely out of the question. What role does Charon play? What hardly anyone knew before New Horizons mission is that Pluto has its own moon, and not just one. Charon is Pluto's largest moon and was discovered in 1978. With a diameter of around 1,212 kilometers, Charon is so large that it forms a highly interesting double system with Pluto because both bodies rotate around a common center of gravity. Outside Pluto, researchers now suspect that Charon is not a real moon at all, but also a dwarf planet that has somehow attached itself to Pluto. This unique constellation has profound effects on both celestial bodies. For example, the gravitational bond between Pluto and Charon leads to remarkable tidal effects on Pluto's surface, which contribute to the geological activity observed there. Pluto and Charon also have a kind of dance, where they always show each other the same side. This synchronous rotation means that Charon always shows the same hemisphere to Pluto, and Pluto always shows the same hemisphere to Charon. The influence of Charon on Pluto's surface is not to be underestimated. Pluto's smaller moons exert strong tidal forces on its surface, which can lead to additional stresses and possibly even volcanic activity. The interaction between the two bodies also contributes to Pluto's complex seasonal changes, as Charon's gravitational pull influences Pluto's atmosphere and surface conditions. The mutual interaction between Pluto and Charon means that Pluto and Charon form a unique double system that has provided researchers with valuable insights into planetary and moon systems. Finally, what are Pluto's moons like? Apart from Charon, Pluto has 4 other known moons: Styx, Nix, Kerberos, and Hydra. They were discovered between 2005 and 2012. These small, irregularly shaped moons are much smaller than Charon and have diameters of only a few dozen kilometers. Their appearance is highly variable and ranges from dark, rocky surfaces to icy ones. The small moons have very irregular orbits and are often the focus of researchers' interest due to their complex gravitational interactions with Pluto and Charon. The moons are important for understanding the formation and evolution of the Pluto system. The interactions between Pluto's moons, especially their tidal forces and gravitational influences, play a role in shaping the dynamism of the entire system. In summary, the New Horizons mission has changed our view of Pluto and its moons fundamentally. Pluto is not the lifeless dwarf planet we once thought it was, but rather a dynamic world with fascinating geological and atmospheric processes. From the strange wandering icebergs and snow made of nitrogen to the intriguing heart-shaped region and its moons, Pluto's exploration has opened up new perspectives on the outer edges of our solar system. Pluto's peculiarities extend beyond its surface and moons, offering deeper insights into its place in the solar system. As researchers analyze the data from the New Horizons mission, several intriguing aspects about Pluto's environment and its interaction with the cosmos are coming to light. One fascinating discovery concerns Pluto's thin atmosphere. Composed mainly of nitrogen with traces of methane and carbon monoxide, it exhibits complex seasonal variations. When Pluto moves closer to the Sun, its atmosphere expands due to increased thermal energy, causing gases to sublimate from the surface. Conversely, as it moves farther away, the atmosphere cools and contracts, causing some of these gases to freeze back onto the surface. This cycle not only affects atmospheric density, but also influences surface features and seasonal patterns, such as the formation and retreat of frost. Pluto's surface is also a canvas of ever-changing landscapes, influenced by both internal and external factors. For instance, the dwarf planet's surface features include vast plains, towering mountains, and complex, multi-layered ice deposits. These landscapes provide a record of the planet's geological activity and climatic shifts over time. Researchers have identified large, polygonal patterns on Pluto's surface that may result from subsurface processes, such as the slow upward movement of icy materials due to internal heat. This dynamic geology suggests that Pluto's icy crust is in constant flux, driven by internal and external forces.
Another area of interest is Pluto's interaction with its surrounding environment. The Kuiper Belt, where Pluto resides, is a region populated by numerous small icy bodies and dwarf planets. Pluto's position in this belt and its unique orbital characteristics contribute to the diversity of its surface and atmospheric phenomena. The interaction between Pluto and the Kuiper Belt's debris can lead to impacts that shape its surface, while the gravitational influence of neighboring Kuiper Belt objects can also affect its orbit and rotation. The study of Pluto's moons, particularly the smaller ones, offers additional insights into the formation and evolution of the Pluto system. These moons likely formed from the same protoplanetary disk that surrounded Pluto and Charon during their early history. The irregularities in their orbits and their varying surface characteristics suggest a history of dynamic interactions with Pluto and Charon, as well as potential collisions and mergers with other Kuiper Belt objects. The exploration of Pluto continues to challenge and expand our understanding of planetary science. Each new finding from the New Horizons mission adds layers to the complex picture of this distant world, highlighting the unexpected dynamism and diversity of our solar system's outer reaches. As researchers continue to analyze the data and prepare for future missions, Pluto remains a symbol of the uncharted territories and the marvels they hold, pushing the boundaries of our knowledge and curiosity about the universe.